Right. Still no Erie? I guess we'll have to get going regardless. Good morning, folks. Hello, hello. We are dealing with the trigonometric functions, right? Specifically, the circular repetitiveness of the trigonometric functions, treated as a function beyond just a ratio of two sides of a triangle. What about as the sides of those triangles change and develop? What happens to that ratio? How does it change in response? That's typically what we look at as a function. It's a relationship between two variable quantities, right? It's not just one thing. There's Erie. Hello. Good to have you. And so, actually, we've got everything on the computer for this, not the iPad. So, yesterday, we talked about, that circularness, and brought up again the unit circle, that most powerful, wonderful of tools that I had already introduced you guys to, and then the book decides to wait until almost the end of the chapter to bring it up. But very handy. So I hope that at least the first page on that sheet was extra easy for you. Let me get the answers on screen. That's the one. So here we go. Circular functions 13.6. Here are the first set of answers there. Go ahead and check your work. I mean, they give us the coordinates, and we're told that, hey, sine is the y-coordinate, cosine is the x-coordinate. It's literally just writing this down. Why is that a thing? Because we need you to burn it into your brain. Sine is the y-coordinate, cosine is the x-coordinate. All right. And here, a little bit trickier. Now they actually give you a real angle, but you can just look that up on your unit circle and say, hey, at this angle, what are the x and y coordinates of that point on the unit circle? There's your sine and your cosine. Done. That said, any questions on the first page? Anybody actually run into an issue? Have something they need to settle with? Confused? Okay, please don't misinterpret my insistence that this is simple as dismissive of your confusion. It's still okay if your brain is not wrapped around it. That's why we're continuing to practice with it. Okay? But I'm trying to set up the expectations of, compared to other things, this one is straightforward. When it's not straightforward, I let you know. I think you've learned that this year, right? Be totally honest with you, which things are hard and which things are not. Okay, so second page is exploiting that periodicness. The fact that it's a periodic function and it repeats itself over and over, and so you can end up with angles that are outside the usual bounds because the domain, right, the allowable inputs to a sine function is anywhere from negative infinity to positive infinity. But one circle is only from 0 to 360. So all of our values come from anything that's less than 360. So we can reduce any larger number to a much smaller number and find it on our unit circle. And that's what we're going to do down here. So here are the answers for those exercises. The exact value for each function, you're like, what the heck? 2,880 degrees. Yeah, it turns out you're spinning in place a whole lot and you land back on 1 anyways. So there you have it. And let's see, can I get 16? Oh, 16 is right here. Okay. So the period of this function. Until you repeat yourself, so you have to go flat, one spike, two spikes, and then the flat one spike, two spikes. So here is the cutoff point between 2 pi and 3 pi. That's 5 halves of pi. All right, any questions from those guys? No? Anybody come up with a clever way to deal with the negatives here? They kind of didn't really tell us in the example. Said, hey, if it's bigger than 360, and this is what I told you guys, if it's bigger than 360, subtract multiples of 360 until it's not, right? But what do you do if it's less than 0? I have positive 240 on my unit circle. I don't have negative 240 on my unit circle. And especially if, do they have a really large negative one? Yeah, negative 750 degrees, right? What's the catch with that one? So our usual, what do I want to say? It's not actually the domain, right? Because the allowable domain is all real numbers. But the ones we want, the ideal domain, I guess you could say, for sine and cosine are going to be between 0 and 360 degrees, or from 0 to 2 pi radians. And so if we are too big, we want to subtract off 360s until we get down to that. What if we do if we're already too small? Well, then we just do the opposite, right? If it starts out negative, start adding 360s until you're back in that 0 to 360 range. Or adding multiples of 2 pi until you are between 0 and 2 pi. So if you're given the opposite sign, and it's, hey, wait, it's negative, it's automatically out of my usual bounds that I prefer, start adding full circles to it until you can find it on your unit circle. Okay, last call for questions before the quiz is. Nothing? You guys got this? We're going to have 100% all across the board? All right. Let's do it. Let's make it happen. So you've got 20 questions of the kind of like, here are, I think it's all cosine, sine, tan. Oh, nope, there's some secant and cosecant. So remember your properties of how to deal with these, right? Secant is 1 over cosine, so you need to invert the usual. But otherwise, everything should be on your unit circle. Have that out and ready to go. And we are starting classic quizzes right now. Go to joinmyquiz.com. Enter the game code 197246. Paste it in Zoom chat for your convenience. 197246. And Erie is making up for lost time earlier, being the first one in. Okay, as always, retake code will be posted at the end of classes today at about 2:30. And when you are done with this quizzes, you can move on to today's practice worksheet, which again is more of the same. Practice doesn't make perfect, I'm told, because it's possible to practice the wrong thing. So I want you to make sure You are checking your work as you go because practice makes permanent. Right? And the more permanent this is, the easier it will be to recall later and makes things like calculus much simpler when you can brush aside the algebra bit because that's coming to you automatically. Okay? That's our goal here. All right, I still need one more of you in. There's 6 of you here. I should have 6. What are we missing? Keep missing. Liana, Henry, Martha. Arlene, where's Arlene? There she is. Okay. Let's begin. Dun, dun, dun. And they're off. Taking a balanced start. We've got a 50% accuracy on the board. And Nathan comes in, pushing that towards positive. We're now up to 67. Excellent beginning. With that, I'm going to wrap up the YouTube stream here.